Gauss's law states that the net outward flux through any closed surface is proportional to the total electric charge enclosed within that surface. But what exactly does that mean? First, let's define flux. Electric flux is the name given to the amount of electric field passing through a surface. The amount of flux is maximized when the electric field lines are perpendicular to the surface and parallel to the area vector of the surface. The equation of flux is given by the dot product of electric field times area, or E times A times cosine of theta. Electric fields parallel to the surface will have a flux of 0 because none of the electric field will pass through the surface. This brings us to Gauss's law. Gauss's law states that the flux of a closed surface, which is the closed integral of the electric field with respect to area, is equal to the charge inside over epsilon naught. Using this formula, we can do a couple important things, like derive the electric field of objects. Here we find the electric field of a point charge, which can be modeled by a sphere. Plugging into the area for a sphere, you get E times 4 pi r squared. Dividing both sides, you get the electric field equals to 1 over 4 pi epsilon naught q inside over r squared, which is the formula for electric field of a point charge. An important thing to remember about Gauss's law is where the particle is relative to the surface. If the charged particle is outside the surface, there will be a net flux of 0, because the amount of electric field going into the surface equals the amount coming out.